This is Concept E classes, and today we'll deal with the question and answers of chapter 16 in class 8 science, light. So before we enter into the exercises, let's take a quick revision of what all we have studied in this chapter. First we saw what is light and how we can see objects. Then we studied about the laws of reflection and the types of reflection. There are two types of reflection, regular reflection and diffuse reflection. Then we saw how reflected light can be reflected again. Then we also dealt with multiple images and a toy called as kaleidoscope and how can we construct that toy. Then we studied about the main source of light, which is sunlight. Then we see things only when light enter into our eyes. So we studied about eyes and what is inside our eyes. Then how can we take good care of our eyes, and also about visually impaired persons and how they read and write, and finally about Braille system. So let's now enter into the exercises. Exercises. Question number 1. Suppose you are in a dark room. Can you see the objects in the room? Can you see objects outside the room? Explain. So we have already studied how we can see objects. We can only see an object when the light from an object enter into our eyes. Hence, to see an object, we require light. In a dark room, is there any light? No, there is no source of light. Hence, we cannot see objects inside a dark room. But if there is light outside the room, then we are able to see the objects outside, as these objects, they reflect the light and that rays of light, they enter into our eyes. Question number 2. Differentiate between regular and diffused reflection. Does the diffused reflection mean the failure of the laws of reflection? So first we have to differentiate between regular and diffused reflection. Then we have to explain whether diffused reflection means the failure of the laws of reflection. So first let's see the difference between these two. Regular reflection, it occurs when the surface is smooth, whereas in diffused reflection it occurs when the surface is irregular. Now the reflected rays are parallel in regular reflection. That is, when the rays of light, they fall on a smooth surface, they are reflected parallelly. Whereas in diffused reflection, when the rays of light, they fall on an irregular surface, the light rays, they reflect in all directions. They are not parallel, they simply reflect in different directions. Now in regular reflection, the reflection is clear, whereas in diffused reflection, the reflection is not clear, it is blurred. Now example of regular reflection is the reflection produced by mirrors, polished surfaces, metals, still water, etc. And an example of diffused reflection is the reflection produced by paper, cardboards, roads, etc. Now the next question is, does the diffused reflection means the failure of the laws of reflection? No, the diffused reflection is not due to the failure of the laws of reflection. It is caused by the irregularities in the reflecting surface, and at each point the law of reflection is satisfied. Question number 3. Mention against each of the following whether regular or diffused reflection will take place when a beam of light strikes. So we have to justify the answer in each of this case. A. Polished wooden table. B. Chalk powder. C. Cardboard surface. D. Marble floor with water spread over it. E. Mirror. And F. A piece of paper. So we have to find out which type of reflection takes place in these surfaces. So let's see. So we know specular reflection or regular reflection is a reflection that occurs on a smooth surface, and diffused reflection or irregular reflection is a reflection that occurs on an irregular surface. So let's see what types of reflection takes place in the following surfaces. So the first one is a polished wooden table. So what type of reflection takes place? Regular reflection. So what is the justification? Here the regular reflection will take place only if the surface is smooth. So when the wooden table is polished, the surface is smooth. Hence regular reflection takes place. Now B. Chalk powder. In chalk powder, what type of reflection is seen? Diffused reflection. Now when chalk powder is spread on a surface, it becomes irregular, not smooth. Hence diffused reflection takes place. Cardboard surface, diffused reflection takes place. Here also The surface of the cardboard is an irregular surface. Hence, diffuse reflection takes place. D. Marble floor with water spread over it. What type of reflection takes place? Regular reflection. When the water is spread over a marble floor, the surface becomes smooth. Hence, if it is smooth surface, the reflection that occurs is the regular reflection. Mirror. It is a typical example of regular reflection, as mirror has a very smooth surface. F. A piece of paper. Here also diffuse reflection takes place. Even though the paper looks smooth, it has very minute irregularities, thereby resulting in diffused reflection. So question number 4. State the laws of reflection. So we already studied that when a ray of light it strikes a mirror, that ray is called as the incident ray, and then after striking the mirror, the ray of light is reflected in another direction, and that ray is called as the reflected ray. Now if we draw a line at right angle to the surface of the mirror at the point of incidence, it is called as a normal. Now the angle between the incident ray and that to the normal is called as the angle of incidence, and the angle between the normal and the reflected ray is called as the angle of reflection. So now let's see what all are the laws of reflection. So the first law of reflection states that the angle of incidence is equal to the angle of reflection, and the second law states that the incident ray and the normal at the point of incidence and the reflected ray, they all lie in the same plane. So these are the two laws of reflection. Question number 5. Describe an activity to show that the incident ray, the reflected ray and the normal at the point of incidence lie in the same plane. So to do the activity, fix a white sheet of paper on a drawing board or a table and take a comb and close all its opening except one in the middle. We can use a black strip of paper for this purpose. Now hold the comb perpendicular to the sheet of paper. Throw a light from the torch through this opening from one side. We will see a ray of light along the paper on the other side of the comb. Now place a strip of plain mirror in the path of the light ray. We can see that after this incident ray strikes the mirror, the ray of light is reflected in another direction, and this ray of light is the reflected ray. Now make sure that the reflected ray, it extends to the projected portion of the paper. Now bend that part of projected portion in which the reflected ray falls. Can you observe the reflected ray? No, the reflected ray that fell along the path cannot be seen. Now bring back the paper back to its original position. We can see the reflected ray. So when the whole sheet of paper is spread on the table, it represents one plane. That is the incident ray, the normal at the point of incidence and the reflected ray. They are all in this one plane. When we bend the paper, we create a different plane in which the incident ray and the normal lie. Hence, from this activity we can say that the incident ray, the normal at the point of incidence and the reflected ray, they all lie in the same plane. Question number 6. Fill in the blanks in the following. A. A person 1 meter in front of the plane mirror seems to be dash meter away from his image. So what will be the distance between the person and his image? It will be 2 meter. How? We know that the distance between the object and the mirror is equal to the distance between the mirror and that of the image. So if a person is 1 meter away from the mirror, his image will also be 1 meter from the mirror. Hence, the image will be 2 meter away from that of the person, because 1 plus 1, which is equal to 2. Now, if you touch your dash ear with right hand in front of a plane mirror, it will be seen in the mirror that your right ear is touched with your left hand. That is, if you touch your left ear with the right hand in front of the mirror, it will be seen that your right ear is touched with your left hand. What do we call this effect as? Lateral inversion. So the image formed by a plane mirror is laterally inverted. It is an effect which is produced by the mirror in reversing the image from left to right. Now see, the size of the pupil becomes dash when you see in dim light. What happens? The size of the pupil, it becomes large. That is, in dim light, the pupil dilates or enlarges so that more light can enter into our eyes. Now D. Night birds have dash cones than rods in their eyes. We know that cones are sensitive to bright light and they're mainly responsible for color vision. And rods, they're sensitive to dim light. That is, they help in the vision during dim light. Now night birds, they see in dim light. Hence, the cones are lesser compared to that of the rods in their eyes. Question number 7. Choose the correct option. The angle of incidence is equal to the angle of refraction. A. Always. B. Sometimes. C. Under special conditions. Or D. Never. So what will be the answer? The angle of incidence is always equal to the angle of reflection. Question number 8. Choose the correct option. Now the image formed by a plane mirror is A. Virtual, behind the mirror and enlarged. B. Virtual, behind the mirror and of the same size of the object. C. Real at the surface of the mirror and enlarged. D. Real, behind the mirror and of the same size. So, what will be the image formed by the plane mirror? We have already studied the features of the image formed by a plane mirror. The image would be erect, it will not be inverted, it will have the same size of the object, it will be the same distance from the mirror, and the image is obtained behind the mirror and it cannot be seen on the screen. Hence, it is a virtual image. So, all these conditions are satisfied in the B option. The image formed by the plane mirror is virtual, it is behind the mirror and the same size of the object. Question number 9. Describe the construction of kaleidoscope. So to make a kaleidoscope, get 3 rectangular mirror strips of size 15 cm long and 4 cm wide. Join them together to form a prism and fix this arrangement inside a circular cardboard tube. Make sure that this tube is slightly longer than the mirror strip. Close one end of this tube with a cardboard disc having a hole in the center through which you can see. And at the other end, touching the mirrors, fix a circular glass plate. Now place on this glass plate several small pieces of colored glass and close this end of this tube by a ground glass plate. Allow enough space for the color pieces to move around and the kaleidoscope is ready. Now when you peep through the hole, we will be able to see a variety of patterns in the tube. Question number 10. Draw a labeled sketch of a human eye. So we have to draw a human eye and you have to label all the parts. Ciliary muscles, the iris, the lens, the cornea, retina, optic nerve, and we have explained about this in the first video of this chapter. If you have any doubts, refer the following slides. Question number 11. Gurmit wanted to perform activity 16.8 using a laser torch. Her teacher advised her not to do so. Can you explain the basis of the teacher's advice? So in activity 16.8, we throw light on an eye with a torch to observe the variation in the size of pupil. And the teacher advises not to use a laser torch for this activity because the laser torch, it has a laser light which have high intensity. So this is a laser torch. And if this light falls directly on human eyes, it might damage the retina and it might even cause blindness. Hence, it is harmful for our eyes and avoid looking at a laser beam of light directly. Question number 12. Explain how to take care of your eyes. It is important to take proper care of your eyes. If there is any problem, you should go to an eye specialist and have a regular checkup. If advised, use suitable spectacles. Too little light or too much light is bad for our eyes. Insufficient light may cause eye strain and headaches, and too much light, like that of the sun, it may injure the retina. Do not look at sun or any powerful light directly. Never rub your eyes. If particles of dust go into your eyes, wash your eyes with clean water, and if there is no improvement, go to the doctor. Always read at a normal distance for vision. Do not read by bringing the book too close to your eyes or keeping it too far. And have a balanced diet. That is, a diet filled with vitamin A. If lack of vitamin A may lead to night blindness. Hence, the diet should include raw carrots, broccoli, green vegetables and cod liver oil, which all are rich in vitamin A, even eggs, milk, curd, cheese, butter and fruits. Question number 13. What is the angle of incidence of a ray if the reflected ray is at an angle of 90 degree to the incident ray? So we have to find the angle of incidence. So by the laws of reflection, we know that the angle of incidence is always equal to the angle of reflection. But it is given that the reflected ray is at an angle of 90 degree to the incident ray. So this angle is actually 90 degree. Hence we can write that angle of incidence plus angle of reflection is equal to 90 degree. But by the laws of reflection, angle of incidence is equal to angle of reflection. Hence, if we substitute this angle of reflection with angle I, then we'll get 2 angle I is equal to 90 degree. Hence, the angle of incidence is 90 divided by 2, which is 45 degree. Question number 14. How many images of a candle will be formed if it is placed between two parallel plane mirrors separated by 40 cm? So when a candle is placed between two parallel plane mirrors separated by 40 cm, infinite images of the candle will be formed because of the multiple reflections between the mirrors. We have explained about multiple images and the multiple reflections caused by the combinations of mirror at different angles in the first video of this chapter. If you have any doubt, please refer the corresponding slides. Question number 15. Two mirrors, they meet at right angles and a ray of light is incident on one at an angle of 30 degree. Now draw the reflected ray from the second mirror. So let's see how we can draw. So here an incident ray at the point of O is reflected and it makes an angle of 30 degree, as the angle of incidence is equal to the angle of reflection. Now this ray of light, reflected ray, it acts as an incident ray on the second mirror, and if we draw a normal at this point, we can see that these two normals, they intersect at 90 degree. Now a triangle is formed. We know that the sum of angles of all the triangles is 180 degree. So we have 90 plus 30, which is 120. So 180 minus 120 will get this angle as 60 degree. Hence, the angle of incidence in the second mirror would be 60 degree. Now the angle of incidence is equal to the angle of reflection. Hence, we can observe that the given ray of light, it reflects from the second mirror at an angle of 60 degree. And we can draw the reflected ray from the second mirror as such. Question number 16. Boojho stands at A just on the side of a plane mirror as shown in the figure. Can he see himself in the mirror? And also can he see the image of the objects situated at P, Q and R? So we have already studied that the plane mirror, it forms a virtual image behind the mirror at the same distance at which the object is in the front of the mirror. So let's say A dash is a virtual image of A, P will form virtual image P dash, Q will form virtual image Q dash, R will form R dash. Now can Boojho standing at A see his own image? No, he is not able to see his image as the length of the mirror is short. Now can he see the objects situated at P and Q or R? He can see the images of the objects situated at P and Q, but not the one at R. Question number 17. Find out the position of the image of an object situated at A in the plane mirror. And can Paheli at B see this image? Can Paheli at C see this image? And when Paheli moves from B to C, where does the image of A move? So let's explain the position of the image and how the objects can be seen. So in the last slide also we saw that the plane mirror, it forms a virtual image behind the mirror at the same distance at which the object is in front of the mirror. Hence the image of an object A will be formed behind the mirror and the position of the image from the mirror is same as the position between A and the mirror. So A dash will be the position of the image of the object A. Now can Paheli standing at B see this image? Yes, she is able to see. Can Boojho also see the image? Yes, Boojho standing at C can also see the image. Now when Paheli standing at B moves to C, will the image move? That is a question. No, the image of A does not move because the image will move only when the object of A is moved. So that's all for the question and answers of chapter 16 Light. Tune in soon for the next session. Thank you so much. May God bless you all. Take care and bye-bye.